Hello everyone, welcome to the lecture again, and this time we are going to discuss something known as function. Okay, so the very first question that might come in your mind is what is a function? Okay, so I can give you one very good example. So basically, in real life, when you're going to do programming, it's going to be very intensive. Okay, uh, let us say you are doing some programming which takes about somewhere around thousand lines of code, so it's a very big program. Okay, so obviously if you write those thousand line of code in a single file, it's not going to be good. Okay, so what we can do is we can create functions. So basically, what are functions? Functions are like helpers, are like servants who are going to take some values, they are going to do some calculation, and then they are going to spit out some value. Okay, so in very technical term I can say they are going to take input arguments, they are going to do perform some operation, and then they are going to uh, give back that value, return that value. Okay, so the syntax of the function is something like this. So first we are going to write down function is a keyword, then we are going to write down art variable, that is the output variable, the return variable, then we are going to write down the name of function, then you are going to write down the argument list, then the help comments statement, then the output variable or the return variable with a value. Okay, so obviously this is not going to make much sense to you now, but once I explain it to you on actual by an actual example, you'll understand what I am trying to say. But remember that this is the syntax of a function. Okay, so if you want to create a function, the very first thing what you are going to do here is, okay, so before that, this is the problem that we are going to solve. This, I think, problem we have already solved for plotting. So let us say use the same problem. So this time we are going to create a function and find the velocity, and this is the equation. So I want to create a function. What I am going to write here, function. So once you write down function, you will notice that it's in a different color. Automatically the color of this word changes. So this signifies that this is a built-in function, no, sorry, built-in keyword of MATLAB. It's a keyword. Those are known as MATLAB keyword. So it's gets highlighted. Then the next thing is going to be your return variable or your output variable. So at present I am taking the output variable as v. So v is equal to the name of the function. So let us say the name of the function is going to be free fall, and then I'm going to take the input. Let us say I'm taking input of three variables: time, mass, and cd. Okay, these are the three input arguments I'm taking from the user. Then what you are going to do here is, after declaring functions, the next thing that you are going to do is you are going to write down the details about the function. It's a very good habit to write down the details, so that whenever a new programmer sees it, he should be able to understand what does the function do. So let us say this is my first function. Okay, then let us write down the equation. So the equation is this, and I'm storing that equation in this variable v, which is nothing but the return variable or the output variable. So what was the equation? The equation is square root of. So in MATLAB I have, I think, already discussed that if you want to find out the square root, you're going to use this function sqrt, then g into m divided by cd, okay, into 10 hyperbolic, then this is going to be square root of G into CD divided by M into T. So what we are doing here is, this is the equation. So we are storing this equation. It's going to calculate, it's going to store in this variable V, which happens to be the return variable of this function. Okay. Again, we have not defined the value of G. So let us say G is 9.81. Okay, and let us suppress this, the output of this, and also the output of this. Let us suppress this output. Okay, so again, one important piece of information, a good habit whenever you are writing a scientific program is to write down the units as well. Obviously you cannot directly write down meter per second square, but yes, you can put a comment. So you are going to say that the units are meter per second square, so that the programmer or the person reviewing this code understands that this is the unit. Okay, now if you have noticed, I have still not saved the function. The function is going to be a separate file, .m file, and one good thing is, whatever name you are going to put here, the same name is automatically going to be for the function. So when you save it, you will see that it says free fall. Automatically it comes here, and then you are going to save the function. Okay, so let us use this function. Okay, so if you want to call this function, you are going to type free fall, then you are going to type let us say this time I am taking as 12, then mass 68.1, and CD, that is coefficient of drag, I am taking it as 0.2. So once you enter this, when you press enter, you'll see that the answer comes out to be 55.86. That is the value of velocity. So this is how you can make use of function. But the more interesting part here is, you can also call this function inside your program. So I have called the function separately, but what you can do is, you can call this function inside your main program. So at present this is my main program here. So let us call this function here. I am defining a variable, let us say x, which is 7. Okay, I want to suppress the output. It is always a good habit to suppress because the output, because your command window becomes very cluttered. Then let us define another variable, z. Okay, now what I'm doing is, here I'm going to call the function free fall, and now I'm going to say that the value of t is 12, this is 68.1, and this is 0.2. So basically what is going to happen here, let me just close this bracket and again suppress the output and display. The velocity is disp. Okay, let us add one more, y is equal to x plus c, and we'll print y. So now when you run this main program, it says that the velocity is 62.86. So basically what has happened here, so this line will get executed when you run this program. This line will get executed, this line will get executed, this is going to get executed. Then when the compiler comes at this point, what is going to happen, the interpreter, that is going to call this function. Okay, it's going to call this function, that, and it is going to take these values. These are known as input arguments. So it's going to take these values, then the function is going to come here, it will take the values, it will do the calculation, then it's going to save it in the return variable, that is e. So the function has done the calculation. Now it has returned the value and it has saved the value in z. Okay, then for the next line what we are going to do is x plus z, and then so this is how you can make use of function. So this is just a very simple program, but in real life when you do very complex programs, okay, when you solve physical problems, real life problems, your program gets very big. So this is very important use of function. And this this style of programming is known as modular programming. Okay, this paradigm of programming is known as modular programming. You break things into small modules and then you call those modules in your main function, and it's very helpful. Okay, so this is how you can make use of your function. Now here you have used one variable. Here you can use n number of variable. You can take a bracket, you can define another variable a comma b comma c and v, and then you can, so here there was in this problem there was just one variable, but you can use multiple variables here, and then you can recall all multiple variables here.